Hi, I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge is climbing stairs. This is a dynamic programming problem. I think we're getting close to the end of the must-know interview questions. The rest of them are dynamic programming problems. Well, dynamic programming, I don't know. To me, it's not the easiest or most intuitive um, algorithm or algorithmic approach. And that may just be me, but in any case, I think it's good to start here with an easy example. What is the problem here? You are climbing a staircase. It takes n steps to reach the top. So there's n steps in the staircase. Each time you can climb either one or two steps. In how many distinct ways can you climb to the top? Okay, let's take a sample staircase here. We have one step, two steps, three steps, four steps. Right, the first two are pretty easy. How many ways can you climb one step? Well, it's just one. How many ways can you climb two steps? Well, you could do one and one, or you could just do two. So there's two ways to climb two steps. Now, how many ways could you climb three steps? Now, keep in mind that what we're trying to get here is not the number of steps that it takes, but how many different ways can you do it? So, if you get to if you can get to step one, or you can get to step two, then it's just one more step up to step three. All right, so you can go from one to three, you can go from two to three, so the total number of ways to get to three is just 1 plus 2. What is the number of ways of getting to 4? Well, similarly, you would add the previous two steps. 2 plus 3 is 5. You're going to get like a Fibonacci sequence if you keep going. All right. Now you could implement this as a recursive solution that is, a typical way of solving a Fibonacci problem. But just a recursive solution is not the most efficient way of solving problems in a lot of cases. And this is one of those cases. One of the cases where it's not that efficient is when you have repeating subproblems. So in this case, you have, let's say, how many ways can I climb 4 steps? All right, so to get that answer, you need the answer to how many ways can I climb 3 steps, how many ways can I climb 2 steps. If you want to get the answer to 3 steps, you need the answer to 2 steps and 1 step. And even though this is fairly small, as you expand it, what you're going to get is a number of, and we have one here already, a number of repeating subproblems. So we don't want to recompute the answer to we don't want to recompute the subproblems. So for two, for example, how many ways can you climb 2 steps? We don't want to recompute it. So we would like to have a way. Well, actually, let me say it this way. There's a couple of ways of doing dynamic programming. One is top down. One is bottom up. Bottom up is really the recursive solution, but we modify the recursive solution to keep track of subproblems as we solve them. Okay, that's called memoization. The other way is top-down, and top-down uses tabulation. So as we compute the answer to a subproblem, we put the result in a table. So why would one method be better than the other? Well, if you have a situation where all of the subproblems have to be solved at least once, then the top-down method with tabulation is better because you've eliminated the overhead of the recursive calls. If you have a situation where some of the subproblems may not ever need to be solved, then the bottom up might be better with memoization. In this case, all the subproblems have to be solved. So what you could do, something like this, is just keep an array where you have something like this. 0, 1, 2, 3, 4. Let me index these. 0, 1, 2, 3, 4. 0 is not in play, but to make this work, we'll just give it a 1. How many ways can you do one step? Well, it's 1. Now, at this point, we can just start adding the numbers together, and we'll get 2, and we'll get 3, and we'll get 5. And we don't have to recompute anything. We just keep filling out the array. So that's the approach that we're going to use for this. And actually, we're going to simplify it a little bit because you don't really need to keep the whole array. I mean, you only need to keep the previous 2 computations. So let's take a look and see how that would work. All right. We're going to have a couple of numbers here. We'll call them previous and current. Now we can do a loop and say for int I equals 1, not 0, but 1. I'll say a little bit more about that in a second. While, okay, and then I is less than n I plus plus. Okay. The constraints here, let's revisit those for a second. The constraints here are that n will be between 1 and 45. It's not going to be 0. So the smallest number we can get in here is 1. If n is 1, we're not going to go through this loop at all, which is fine because there's only one way to climb one step. Okay? Let's do this. If n is bigger than 1, I'll say it's 2, then the next number is going to be previous plus current. And then we'll adjust the numbers to say previous is now equal to current, and current is now equal to next. Once we get through the loop, we can return current. Okay, so that's what I was talking about when I said we don't need to maintain the whole array and then do lookups into the array. We really only need two numbers at a time. And from that, we can calculate the next number and toss out the previous number. We need previous, current, and then to get the next number, add previous and current, throw out previous. So that should work. We've taken the recursion out of it, and so it should be a more efficient solution. Let's try it. All right, accepted, and submit the whole thing. Yeah, that's pretty it's pretty efficient, but it looks like everybody gets it that way. Well, actually, you know what? I thought this was interesting. If you look at the topics here, it's dynamic programming, yes, memoization, but memoization is bottom up, which means that we're still going to do the recursion, but we're going to maintain a lookup table for solutions. You know, once we solve them. Now, as I said, if you have to solve all of the subproblems, which in this case we do, then this is not the most efficient way to do it because you have the overhead of the recursive calls. So if you can do it this way, which is top down with tabulation, it's more efficient, not memoization for this. All right, that's it for climbing stairs. I hope you enjoyed it. Please feel free to like, comment, subscribe, and see you next time.